How do we go about mistake-proofing our product design? There's a checklist we can use based on a well-known manufacturing production method, Poka-Yoke. Let's talk about Poka-Yoke for product design after this brief introduction. Hello and welcome to Quality During Design, the place to use quality thinking to create products others love for less. My name is DIANNA. I'm a senior-level quality professional and engineer with over 20 years of experience in manufacturing and design. Listen in and then join the conversation at qualityduringdesign.com. Today we're talking about mistake-proofing the user process of our product design, specifically using some Poka-Yoke methods. If you go to this podcast blog on qualityduringdesign.com, you'll see an offer for a free mistake-proofing checklist, something you can download and have available for when you're ready to mistake-proof the user process for your design. We can evaluate our product design concept with a user process analysis. We can use a process flowchart to detail the steps our users need to take with our product to achieve a result. Knowing our typical users and the environment in which they'll be using our product, our team can examine the process flow map and find areas where mistakes are likely to happen. This is great to do early in the concept phase because it helps us with design features. We can continue to develop the flowchart throughout the product development process, getting more specific with the steps and the mistakes as we get more clarity about what components are part of our design. Features that are designed into our product to stop user mistakes from happening are a type of preventive control. Features designed in to help identify that a user mistake has happened is a type of detection control. Preventive controls are best because they help us avoid the error altogether. If we can't prevent the error but still need to either ensure it doesn't happen or it gets fixed quickly if it does happen, then we start using detection controls. To help us decide on what type of controls we can and want to use for our product design, we can step through some choices by using a standard quality tool for manufacturing, Poka-Yoke or mistake proofing. Shigeo Shingo was a Japanese industrial engineer who was part of the acclaimed Toyota production system, a management system. He's credited with coining Poka-Yoke in the early 1960s. Poka-Yoke is a Japanese term meaning mistake-proof. It started out as Baka-Yoke, which translates to idiot-proof. The story goes that people were evaluating a production process on the floor during production. An operator overheard them talking about Baka-Yoke and burst into tears, crying, "I'm not an idiot!" The name was afterwards changed to mean mistake-proof or Poka-Yoke. Besides avoiding hurt feelings, Poka-Yoke is focused on activities and not the person anyway. Really, we're addressing the root cause of an error. People are not root causes of issues. There's always another root cause either before or after a person made this mistake, something we can act against to correct the issue. The Poka-Yoke mistake-proofing philosophy is part of Lean and Six Sigma methods. We're either making a mistake easily noticed or preventing it from happening in the first place. There are two cornerstones of this method. It should be easy to the point that it's almost obvious after we've done it, a type of thing where we ask ourselves, why weren't we doing this already? And it's close to the point when the error was made. It either prevents a mistake or lets us know about the mistake soon after it happens. If caught immediately, the error can be corrected right away to avoid further issues. This has a lot of benefits. We learn from our mistakes, so it helps prevent a reoccurrence of the same issue. It helps to identify the source or cause of the error when we're notified quickly that it's happened. It can also save costs, headaches, and other bad things because we fix an issue right away. We're not building out from the mistake, realizing it much later, and then having to do a lot of reworks to fix it. Poka-Yoke is typically an industrial engineering, manufacturing, and production method. But Poka-Yoke can be applied to the user process too. Mistake-proofing the user process with the product design can help to avoid injuries and disappointing product performance. Whenever people can make a mistake with our product, that could be an opportunity to mistake-proof it with a design. If we have a detailed flowchart of the user's process, the steps they take to use our product, we can examine where human errors are likely to happen. Then we find the source of the error or its root cause. It's likely to be within that process step or one that's before it. For each error, we think of ways we can mistake-proof it. What can we change about the step where the error occurs? Can we make it easier to perform the step as desired and at the same time harder to create an error? Can we do the step differently or replace it with a different type of action? Or can we eliminate the step altogether? Can we perform checks to ensure certain conditions are right before the process step can get started, like an automatic or designed-in measure? If we can't prevent mistakes from happening with the way the product is designed, what can we do to easily detect it? We can think of mistake-proofing as inspections by the users. There are 3 dimensions of mistake-proofing. One dimension of inspection is a combined who and when an inspection occurs. A second dimension is the way the inspection is performed. And the third dimension is about how the inspector, our user, is notified that there is an error. First, let's talk about who or when an inspection occurs for an error. There are 3 levels. There is a source inspection, a self-inspection, and successive inspections. Source inspection checks are those that are done before the next process step. They're usually automatic and prevent the user from completing a process step if the conditions are not correct. Source inspection checks should be designed-in preventive measures. Self-inspection is done by the person who is using the product. The inspection is performed immediately after they've completed a step, after the fact. This allows for detecting if an error has occurred immediately after when it could have happened, so the user might have a good chance of correcting the issue before it turns bad or tragic. Successive inspections are performed by the next user of the process. It might be a good time to do this type of inspection if there's a handoff or transfer immediately after a process step. The second dimension of Poka-Yoke is the way things are inspected, the methods. There are 4 general types of methods. Physical methods uses physical design features or characteristics to reduce errors. Step sequence methods check the sequence of steps to ensure the right things happen in the correct order. The grouping and counting method counts or measures parts to ensure the step is complete. And information enhancement methods provide information to the user, so it's available and perceivable when and where it's needed. The third dimension is signals, sometimes referred to as regulatory functions. These are warning functions like alarms, bells, whistles, and flashing lights, and control functions that prevent the user from proceeding in the process until the error is corrected. Let's talk about some examples from our everyday use. Computer cables are designed to only fit together one way. Maybe they're shaped and pinned in a unique way, like a printer cable, or maybe they're keyed. The type of inspection for this scenario is a source inspection because they're automatic and prevent connectors from joining in the wrong way. The type of method is a physical method because the design is physically preventing us from completing a step unless we've done it correctly. Another example is that we picked up some self-assembly furniture and we checked the contents of the box against the parts list in the instructions before we start assembling it. The type of inspection this is a successive inspection because we're the next user of the assembly process. Someone put the contents in the box, now we're opening it to use it. The type of method it is its grouping and counting because we're literally counting groups of parts to make sure we have what we're supposed to have. We pass our technical report through a spell checker or Grammarly before we publish it. This is a type of inspection that's a self-inspection because we're doing it after we've created a report. The method is information enhancement. Misspelled words and bad grammar are highlighted for us to easily see and gives us options for us to correct. Powered miter saws require a single-handed brake release button and trigger that need to be pushed at the same time. The type of inspection is a source inspection check because it's designed in, and we can't start cutting with the saw unless the switches are both engaged. The method is a step sequence method because it ensures that we first release the brake, then pull the trigger for operation. I hear a buzz sound when I don't remove my credit card from the machine after it's done reading it. The noise is meant to alert me and to tell me to take my card with me. This type of inspection is self-inspection because we're the ones inserting and interacting with the credit card machine. We're supposed to ensure that we've taken our credit card once we're done with it. The method is information enhancement because it's letting us know before the cashier gives us our purchases that we haven't completed our steps and taken back our credit card. The alert it's giving us is an auditory warning function that we need to take action to prevent an error, namely leaving our credit card behind. Let's do 2 more examples. I turn off the engine in my car while it's still in drive. The car gives me a jingle and a bright orange message appears in the dashboard. I've forgotten to put the car into park. This is a source inspection because it's automatically checking that all the conditions are right for the car to be parked and left. The method is physical because there's a sensor checking that the car is physically in park. The alert is a warning function in that it gives me a lot of visual and audible warnings that something wasn't done correctly. The self-checkout system at the grocery store won't let me scan another item until I've placed the previous item into the bagging area. This type of inspection is a source inspection because it's automatically checking that I'm scanning and bagging one item at a time. The method is grouping and counting because it's using weight to ensure the process step of scanning one item is complete. The type of alert is a control function because I cannot continue scanning my groceries until the sensor in the bagging area submits the correct weight or the attendant visits me to apply an override. As you can begin to see, there are a lot of mistake-proofing examples in the designs we use every day. Leave me a comment in the podcast blog about another one you've noticed. What are our insights to action today? Even if we cannot design out all user mistakes with our product, there are probably things we can do to design in Poka-Yoke inspections. They're easier to notice and plan for if we have a user process flowchart. Waiting for the user process to be all done before we look for use errors is too late in the design process, so we're going to do it early and iteratively as our design concept gets defined. We make mistake-proofing methods easy, nearly obvious, and close to the point the error was made. To help us apply Poka-Yoke to the user process, we can look at it from 3 standard dimensions: who and when an inspection occurs, the method of inspection, and if there are signals or built-in controls. And don't forget, if you visit qualityduringdesign.com at this podcast blog, you'll see an offer for a free mistake-proofing checklist. You can print it out and have it handy when you're deciding how to mistake-proof the user process for your design. If this episode was useful, there's a previous episode of Quality During Design that you might find helpful. Episode 29, Types of Design Analyses Possible with User Process Flowcharts, reviews the process flowcharting method. Please go to my website at qualityduringdesign.com. You can visit me there, and it also has a catalog of resources including all the podcasts and their transcripts. Use the subscribe forms to join the weekly newsletter where I share more insights and links. In your podcast app, make sure you subscribe or follow Quality During Design to get all the episodes and get notified when new ones are posted. This has been a production of DIANNA Enterprises. Thanks for listening.